Hello everyone, welcome back to Pavani Teaches. In this video, we are going to discuss few array problems. So, I brought here four problems. One is reverse an array, finding the second largest element, check whether array is sorted or not, current occurrence of an element, like it will have some key element and we need to check the how many times that element has repeated. So now let's solve one by one the problem. Reversing of an array. Like if suppose we have an array like this, like 1, 2, 3, 4, 5, and we need the output as like this, that is 5, 4, 3, 2, 1. So one thing is reverse traversal. Like reverse traversal means using the for loop and starting the index that is as I equal to 5 minus 1, which is the size of an array, and minus 1 because index is like ends with n minus 1. Okay, 1. Directly you can write here 4, and I should be greater than or equal to 0 because index of an array starts from 0. Like we are doing it from last to n, and I will be decremented every time because we are printing from the last to the first. So index of an I will be decreased, and then we will just print array of I. This is known as reverse traversal. I hope you got it. Now we can make reverse traversal, but we need to change it. We need to modify the given current array, like we need to reverse it. That's when we use two pointers approach. Two pointers it is nothing but we'll have like two locations where the two locations will point the different elements. Here, if we observe, like output we are wanting is this. So here what we observed is the first and the last is being swapped, and the last second, like the second one and the last second is being swapped, and the middle one is middle one. Like we don't have any other elements to swap, the middle stays the constant. So what we observed is the elements are being swapped, which are the first element, ith element, and n minus 1 minus I. Let's check it practically. So the array we have is 1, 2, 3, 4, 5, where indexes is 0, 1, 2, 3, 4. So what our plan is, like we want to swap I, like 0 to the n minus, where n is 5, minus 1 minus I, which is 4. So 0th index is being swapped with 4th index. That means these two are being swapped. So let's swap it. 5, 2, 3, 4, 5. Sorry, 1. And then the I will be like increased, and now 1 will be swapped with 5 minus 1 minus 1, because the index of 2 is 1, which is the value is 3. So first index element will be swapped with third index element. Let's just swap it now here. 5, 4, 3, 2, 1. What, like again the increases. Now I will be 2, and let's check 5 minus 1 minus 2, which is 3. So 3 is equal to 3. We don't need to swap further. Like we need to stop when it reaches where I is less than or equal to n by 2. Okay. Now let's code it up. The question. This is the explanation part of reversing an array. Let's code it up in VS Code. I'm going to import the file, like import java.util.star, where all the packages will be present. Once importing is done, I'll just create the class where public class reverse. And inside the class, I'm going to create main method, public static void main, void main, and strings, string, we are done creating the file. Now, directly I'm just gonna take the array where array is equal to 1, comma 2, comma 3, comma 4, comma 5. So I want this array to be reversed. So as we discussed, the logic is like for we need to take for and I is equal to 0 unless I should be less than 5 by 2, which is 5 is the size of an array and 2 is like we need to check until reaching the half of the array and I will be incremented. Now we'll just swap it. So to swap it here, I'm going to take int p1 and p2. So here, now p1 will become I and p2 will become, yeah, 5 minus 1 minus I, as before explained. Now we are going to store some another temporary variable to swap it. Int temp equal to array of p1 equal to like array of p1, like we are storing the first index, in a temporary variable, and then we are going to swap with the p2, that is array of p2 equal to array of p p1 p1 and array of p1 equal to, here it is going to we need to store the p2 value. That's it. Like we are swapping the first and the last element if I is equal to 0. And if I is equal to 1, we are going to swap the second and the last to second element. Like you need to do the dry code like here. Let's just do the dry code like for I is equal, like int I is equal to 0, I less than 5 by 2, I plus plus. So at beginning I am taking P1 as something I and P2 is equal to 5 minus 1 minus I. And now at when I is equal to 0, you need to take it like 0. Temp of temp will be array of P2, as I said. P2 in the sense it is the value is 4, as before we did array of 4, and then array of 4 P2 will be equal to array of, like you're storing the array of 0 in array of 4, like you're swapping it, and then array of 0 will be temp. That's it. This is like at beginning we are storing here 5 value, and in the place of array of 4, like at the fourth index where we have 0 1 2 3 4, we are going to store the first element. The step tells the first element. Then here at the zeroth position, we are going to store the temp where which is the last element. That's it. This is the logical part of the code. Now let's print the array. for in I and array. I'm just using the enhanced for loop to print the array. That's it. Let's, I think this is for the code. Let's just compile the code and run it. Reverse dot java, sorry, java c reverse dot java, and then we need to run the code java reverse. Yeah, we can see the output. That is 54321. Hope and our code works. This is how you need to reverse an error.
Now we are going to discuss finding the second largest element in an array.
Like we need to sort an array. If we sort this array, given array, we'll get like answer is like five. Array will be 4, 5, 6, 7, and 8, and the second largest element will be the 7. And if we see the practically the time complexity it will take is n of log n. It takes this complexity to sort the array and to access the n minus 2 element of an array. This is the second largest element of an array. So to reduce the time complexity, can we do it in an order of n time? Yes, we can do it using a DSA. Like using like considering the two variables, one is the largest and the second largest. So here when we're doing with second largest element, like we need to check with the two conditions that if the given like if the coming array of I is greater than largest, then we will first stores the previous largest element to the second largest. Then we update the current largest element with the current element. So after writing this code, and you'll just dry run the code, then you'll get to understand it. And the another condition that we need to check is if array of I is greater than the second largest, and array of I is and array of I is not equal to the largest, then we can just update the second largest element to array of I. We'll do this in code also. No need to worry about the syntax and all. Try to understand the logic for now. And now here I'll run the code like at beginning for I equal to 0, I less than yeah, n in the sense 5, where array is 5 here, and I will be incremented all the time. At beginning we'll take the largest. This will be outside the for loop. The largest and the second largest will be the initialized with the minus infinities. Then uh, we'll start the for loop and checks if array of I is greater than the largest. Yes, obviously 4 is greater than the minus infinity. So we'll just store the second largest. Second largest will just store the largest value in the second largest. That means minus infinity, because the first we are initializing with the infinity minus infinity and updates the largest value to the 4. Now our largest, I'll just keep the track of largest and the second largest here. Now it will be the 4 and minus infinity. Okay. Uh, if this goes into the if condition, not needed to check with the if else if. So I will be incremented and now the element will be 5. if 5 is greater than the largest, if 5 is greater than the 4, yes, obviously it is like greater. So we need to update the second largest to the largest. What is the previous largest? That is the 4. We'll update the second largest to the 4 and update the largest to the 5, like current element, which is current. So here 5. Okay, I hope you got the, like how our logic is working. And then the 6. If if 6 is greater than the largest, yes, it is greater than the largest. Second, we'll just first store the previous largest element to the like second largest, and then update the current largest element, that is 6. Okay, that will be given to check with 7. Now I'll just change the value 7 into the 3 here. Yeah, for better understanding. If 3 is greater than the largest, no. So we don't check, like check this, go into this if condition, and it will check. Let me, yeah, okay, and it will check if array of I is greater than the second largest. No, that is also like 3 is not the greater than the 5, and it is not equal to the largest. It will not also go into this for if else if condition, and I will be incremented with 8 and checks if 8 is greater than the largest. Yes, it is greater than the largest. So we'll update the second largest element with the previous largest element, that is 6, and here the largest element will be updated with the current element, that is 8. So what is our final largest element, that is 6. So this is our answer accordingly. So let's just code it up and check with like another example if this code works or not. So here I'm just writing the main method, that is public static void main string args. Before this I'm gonna just import java dot util dot star, and here I'll take some new array, that is array will be the something like 3 comma 4 comma 7 comma 1 comma 6. Let's take 5. Yeah, that's it. Now, as before I said, we need to consider like two variables, that is largest, which is equal to integer integer dot v9. That's it. And we are going to take another variable, that is int second equal to integer dot mean value. Like both are it is equivalent to the taking infinite value, like minus infinite values. So we'll run the for loop, and it starts from I is equal to 0 and I less than 5, which is the size of an array, and then it will check if current array of I is greater than the largest. Then we are going to update the second element with the largest value, and then we'll update the largest value with the array of I. And our next condition is else if array of I is greater than the second, it is, and it is array of I is not equal to the largest, then we will just directly update the second to the array of I. That's it. This is for the code. Now outside the for loop, let's just print the second largest element. Print the second largest element. So I'm going to run this code and check if this is working with no errors. I'll compile the code and run it. Yeah, we can see the second largest element is 5. Let's just check it. What if we write in a sorted manner 1 comma 3 comma 4 comma 5 comma 7? So yeah, we got the correct answer, which is 5. This is how you need to find the second largest element in a time complex of order of n. And our next question is finding finding the array if the array is sorted or not. For example, here we have the example array is 1 comma 2 comma 4 comma 3 comma 5. Let's just check like how are we checking the given array is sorted or not. Like we are going from the 1 2. If these two numbers are sorted, yes. And next we are checking with the 2 and 3. Is 2 and 4 is 2 is less than 4? Yes, it is lesser than the 4. Then we check with the 4 and 3. If 4 is lesser than 3, no, it is not. So the given array is not in a sorted manner. So what we are doing is like checking with array of I with array of I minus 1 element. Okay, let's do it like we'll just run in where I equal to 0, I is equal to 1 and I less than 5 and I plus plus and checks with this condition. If this condition fails, if this condition like we'll just check it. If this fails, we are gonna change the flag that is sorted into false. That's then end the for loop. At beginning, we'll take sorted is equal to true. Like we'll consider the given array sorted. So let's do a dry run code. The logic is very simple. We'll just compare with the ith element with the ith minus element. So we have here 1 comma 2 comma 4 comma 3 comma 5. So here at beginning the I starts from 1. Okay, that means the second element. Sorry, it is not equal to. If this is if array of I is l- less than array of I minus 1, like you can get to know here. Like it will check if 2 is uh, less than 1, which is your it is the first index and it is the second index element. So it checks if 2 is less than 1, no, it is not. So it will not go into this if condition. The I will increase and checks with if 4 is if 4 is if 4 is less than 2, no, it is not. So it will not go into this if condition. So the I will be increased and checks with if 3 is lesser than 4, yeah, this condition is getting true. So then it will go into this for loop and change the sorted boolean value into false. That means here it is indicating the given array is not in a sorted manner. So we will just break the for loop. I think you got the main logic that we are like comparing with the two adjacent elements. If the current element, like if this given this uh, ith element is greater or not, like you can change the if conditions like as your wish, but the main logic is you're checking with the two adjacent elements if they are in a sorted or not. That's it. Let's just code it up quickly. I'm just again creating public static void main args and taking here array equal to something 1 comma 2 comma 4 comma 3 comma 5. And then when I equal to 1 and I should be less than 5 with this size of an array and I will be incremented. And it checks if before this I am just gonna take another like boolean value which is boolean sorted. At beginning we will consider the given arrays sorted array. So sorted is equal to true if array of I is lesser than array of I minus 1, then if we go inside a for loop and change the sorted into sorted value to false and breaks the for loop because we don't need to like check the further and print the value of sorted. Yeah, let's run the code. Java C sorted dot Java. Java sorted. Yeah, we can see the output that is false. As we have seen, like here the 3 and 4 are in a same manner. If 3 is here and 4 is here, then we can see it is sorted. Shall we compile it and check if we get the true or not? Yeah, true. We got the correct output. This is how we need to sort. Like check if the given array is sorted or not. And our next question is counting the occurrence of an element. It is like a linear search manner. Like we'll just traverse to the array from I is equal to 0, I less than n, and I plus plus. And check if given key, we'll take here key is equal to 5 as given. If area of I is equal to key, then we take another variable which keep the track of the count and bring the count will be 0. If the area of I is equal to key, then we increase the count value. That's it. Like it is like normal linear search as before I have explained in previous video. Okay, and at last we will just print the count value. That is that will give us the count of occurrence of an element in an array. It is like simple question. I am not giving the code. And now here, these are the extra 5 questions. I am just letting you to learn self-learn, do self-learn and practice it. And by these questions, like you can make the arrays basics as the best foundation for DSA. That's it. That's it for this video. Please do subscribe and our next coming video is on strings. Stay updated.